The last thing we're going to look at in terms of regression slope, t-tests, and t-intervals is the idea of using computer output. And so you should remember this stuff from earlier in the year, but in case you don't, just to remind you up here we have our y variable, and that is electrical usage, and that is kilowatt hours. We also have, down here, we have the x variable. We have degrees of freedom right up over here, so 10 degrees of freedom. Next to the x variable right here is our slope, and right above that would be the y-intercept. And now there's three numbers that we did not talk about in there that we're going to use now. The numbers next to the slope, so 4.98, that is the standard error of your slope. The number next to that is your t-score, and then the last one over here is your p-value. So literally right now the computer output tells you a lot of the information that you need here to actually go ahead and work with all these problems. And then you can tell in this case here that your t-score is a really small number here, and your p-value is really, really small. So at a certain point the computer output will just say it's less than 0.0001, and that's fine. So let's go ahead now and answer our questions here. So first of all, the question is there evidence of an association between average monthly temperature, which was our x variable, and electrical usage, which was measured in kilowatt hours, which is our y? So first of all, you want to state your hypotheses, and then we're also going to make a conclusion about our p-value that we already know from reading the output. So the hypothesis I have is that there's no association between the two variables. That would be our null, and our alternate would be, yeah, you know what, there is. We also would write that as beta sub 1 equals 0. In other words, the slope would be basically 0. And then over here it would be the slope is not equal to 0. So based on the p-value, if you go backwards here, this p-value right here tells us that we would end up rejecting our null hypothesis. So we're just going to jump right into our conclusion here. So we reject HO since p is less than 5%. And you'd say there is strong evidence of an association between these two variables. So there is strong evidence of an association. And then make sure you go ahead and use context in this case here. So it's between monthly temperature and electrical usage. So this is really easy to do. All you have to be able to do is look at your computer output, be able to read it correctly, and then interpret into context here. So between electrical usage and monthly temperature. That's that. The other part of this is to actually be able to do a confidence interval. So, as we were already discussing earlier, if we actually have data, we have to do more calculations here. But what's nice about the actual table is we know the slope. So once again, if you go back here, we know the slope, we know the standard error, we also know degrees of freedom. That's all stated for us here. So we can use that information now to actually do our confidence interval here. So the slope is, in this case here, negative 50.903. Then we have plus or minus t star, and the degrees of freedom would be 10, and then it turns out that our standard error, we already know what that is 4.98. And we can get that once again just from reading the actual computer output. Alrighty, and then go ahead, grab your table and find out what t star with 10 degrees of freedom is, and according to my table it's 2.228. You can go ahead and multiply these together here, so you get negative 50.903 plus or minus, and I got 11.095. And when you go ahead and do the math on this, you should wind up with this as your interval. You should wind up from negative 61.998 on the low end, and the high end should be negative 39.808. And then all we need to do at this point is go ahead and write it into words. So we say we are 95% confident, and as always, this is about our slope in this case here. So slope once again is delta y over delta x, and y in this case was electrical usage, so I'm going to say ELECT, and x in this case was the average monthly temp, so I'm going to say just temp here. So we're 95% confident that electrical usage, and we would say decreases because we have negative numbers up there, and we could say decreases 39 point, I'm going to call it 0.8 here, round to the nearest tenth, 2, and round this off, that would be 62 to 62 kilowatt hours per increase, and I believe it was 1 degree Fahrenheit increase in monthly temperature. I believe that was the units back there. I don't think it was mentioned on there, but I know from actually seeing the problem there. So in monthly average temperature. So there you have it. That's how you make an interval using computer output.